This question asks, what is the empirical formula for ethyl fluoride if the compound contains 49.97% carbon, 10.51% hydrogen, and 39.52% fluorine by mass? So there's a step-by-step process to find the empirical formula. And the first thing that we're going to do is assume 100 grams. And this makes our life a lot easier because we know that 49.97% of 100 grams is just 49.97 grams. So we know we have 49.97 grams of carbon, 39.52 grams of fluorine, and 10.51 grams of hydrogen. And this is all based on our percentages given in the problem statement. So the second step that we're going to do is convert grams to moles. And definitely in the third step, it'll also make sense why this is so important and makes things easier. So we can convert grams to moles using the molar mass of each component. So if we start with carbon, we have 49.97 grams of carbon, and we'll use our conversion factor that for every 1 mole of carbon, we have 12 grams of carbon. And this gives us 4.164 moles of carbon. And in a similar way, we can do this for hydrogen and fluorine. For every 1 mole of hydrogen, we have about 1 gram of hydrogen. So this gives us 10.51 moles of hydrogen. And lastly, we'll do this for fluorine. And we get 2.08 moles of fluorine. So to find the empirical formula, it all depends on ratios. So to get those ratios, we're going to divide by the lowest number of moles that we found in our calculation above. So we're going to divide by 2.08 moles of fluorine because that's our lowest number of moles. And we're going to first do this with carbon. So we have 4.164 moles of carbon. We're going to divide by this lowest number of moles, 2.08 moles of fluorine. And we're going to end up getting 2 moles of carbon per mole of fluorine. And so that's our first ratio we're going to use to find our empirical formula. And we can do the exact same thing with hydrogen. So we have 10.51 moles of hydrogen divided by 2.08 moles of fluorine. And we're going to get that for every mole of fluorine, we have 5 moles of hydrogen. So now we can find our formula because we know for every fluorine, we have 2 carbons based on this ratio and 5 hydrogens based on this ratio.